Hey everybody, and welcome to McArdle Math Academy. In this video we're going to be talking about volumes of revolution, and we'll be one specific example. So the example here is to find the volume of this red region that I drew here that's rotated about the line y equals 8. So the region that we drew here in red is bounded by the line y equals, the curve y equals the square root of x, the line x equals 16, the x-axis, which is y equals 0, and we're going to rotate that up here about the line y equals 8. So you first have to think about what this looks like in 3 dimensions. So here's the axis of rotation, and when we spin this about this axis, you're going to get a large cylindrical looking object, somewhat like this. All right. And inside of this object, when we spin it, we're going to have a large opening with the cylindrical cutout on the inside. So all of this stuff in here is open, and the rest of this is a solid figure on the inside of this cylinder. Alright, so when we look at this figure, we need to find the volume, and therefore we have to draw a disk. So let's draw the slice here for a second. So here's one slice that you can see here in blue. It's got a thickness of dx, and if you look at the shape of it, it's actually the shape of a washer. Alright, so now we know to set up the integral for this volume, we're going to first have to find the volume of that one slice, which in this case is a washer. So when we learned the washer method, we know that the volume of this slice is going to be pi times big R squared, which is the farthest distance or the farthest radius from the center or from the axis, minus little r squared, which is the smallest distance or the small radius from the axis. So let's try to find what r and little r are in this case. And we come back to the two-dimensional and three-dimensional figures to try to figure out what these are for our particular functions. So let's start with little r. Little r is the distance from the axis to the first graph that we come across, which is here. So that's little r. And you can also see that it's also this distance here. Alright, so let's come back to the two-dimensional figure to draw that little r on this graph here. Here's little r. And we need to figure out what this distance is in terms of x. Why x? Because our variable of integration here is x. The thickness of the slice is dx. So let's try to figure out what little r is. And from the graph, we know that the distance from the x-axis up to this graph is represented by the square root of x. And the whole distance to the top is represented by 8. So you can see that little r would then be 8 minus the square root of x. Alright, so we'll bring that back to plug in for little r in the volume of our slice. Alright, and next we have to look for big R. So big R is the distance from the axis here to the farthest point on this figure, which is going to be up here. And therefore that's the same distance as this distance down here, which is big R. And this one's pretty easy because on the two-dimensional figure, that's the distance from here all the way down to this x-axis, which we know is always 8. Alright, so let's bring all of that information back to the equation for the volume of our slice. So we get pi times 8 squared, which is 64, minus 8 minus root x squared dx. And I'm just going to expand this out so that we can get it in a more simplified version before we take our integral. So we arrive at an equation for the volume of our slice. Everything's in terms of x, which is a good sign. And therefore we just have one last piece, and that's to set up our integral. So remember that the integral will be of the volume of each slice, so we bring down that formula. And then we just have to find the bounds on our integral. So x, if we look back at the figure, x ranges from 0 to 16. So the smallest x will ever be is 0, and the biggest is 16. So we'll bring those bounds to our integral on this side. And then it's just basic calculus from here. So you're going to take an integral. We'll get x squared over 2 plus x to the 3/2 over 3/2. And we're going to plug in 0 to 16, and of course there's parentheses around this whole bunch here. And when we do that, we'll get pi times 16 squared over 2 plus 2/3 16 to the 3/2. All right, I'm going to simplify this for a second. So we arrive at the final answer of 512 pi over 3, and again that represents the volume. So let's zoom out here so we can see the whole procedure. That represents the volume of this figure, which was rotated about the line y equals 8. So the hardest part here was finding big R and little r based on the figure. All right, hopefully this helps, and I'll see you guys next time.